this okay too much? All right, it'll be okay. It's okay. Thank you for having me. It's been an incredibly stimulating weekend, and I will try not to use this to forget what I've learned. But fortunately, I've got the benefit of my memory prosthetic to keep me somewhat focused. I'm probably going to rename my talk a few times through the talk. One of the dreaded question that I have that gets posed to me is, so what do you do? This is the most concise way I know how to answer the question. Is this approximately 40-minute journey we're going to go on into stuff that I've done. I don't know. I imagine some of you have the same thing. Somebody asks you what you do, and you kind of look at them like, which answer are you hoping to hear? Right? It's like, so one of the things I do is I will often wear T-shirts, and people will say, "Oh, I was there," or "I know what that means," and give you a little bit of a clue as to like which answer would best suit the asker. So that's essentially what I'm going to do. Most of the time, what it looks like I'm doing is this. I make electronic music instruments, and I play them live, and I try to, as much as I can, improvise with them, and do that with other people. And I do that, I try and do that in big situations with real, live, goofy audience members, where they really don't want to hear something crappy. They would like to hear, the audience wants to hear good music, right? The audience wants to hear music. So they don't want to hear a demo, they don't want to hear the sound of your computer reboot, and they don't want to hear, I don't know if you've ever been to a concert where someone has resoldered their thing that they've just made. There's nothing quite like the ambiance of a live concert with the smell of solder in the air. It's an experience to have once. It's kind of cute once, but after that it's not. Right? So one of the things that I do is I play concerts. I play improv concerts because I feel in a way that it keeps me honest. What I'm really interested in is, when does something go from being not an instrument to an instrument? So a violin goes from being a tree to being an instrument. And at some point, in a Luther's woodshop, or when it's in the hands of a skilled player or something, we say that is an instrument. And it's probably somewhere before it starts making music. We say now it's become an instrument. And I'm really interested to find the time when we flip from saying that's some wood with some potential to being an instrument that could be beautiful. I want to find what that is, and I think that it's not only possible, it exists for digital instruments as well. I'm not claiming that I've made a beautiful digital instrument, but I'm searching for it, and I'm searching for the time when we can point to saying this is how we make them, and how other people could go about making their bits of silicone, or whatever it is you're using to make your instruments, when you flip over to something else. Okay. Not being a collection of stuff, but being a fully formed instrument. So what I'm going to do is I'm going to start to describe the main instrument that I've been playing on for about 10 years now. I'm going to show you about how I think about, how I started to think about making an instrument. And what I think is really interesting is looking at how people deconstruct problems, because then it gives you a little bit of an insight as to them. So you're about to see into my brain. Well, not really. This is going to be really anticlimactic. I'm going to change the slide, and it's just a bunch of text. So it started out as in the beginning, I went to music school, and what happened was I was trained to be a percussionist, classically trained percussionist, and I could do all this stuff with my hands. I can do things. I can get sounds, and I can change sounds depending on how I hit things. And I know how the table is going to sound before I hit it, just from years of hitting tables. Really, that I know what's going to happen. And so someone said, towards the end of my time in music school, someone said, "Hey, here's a computer. Did you know it can make sound too?" No, I didn't know it could make sound. And so I tried making sound with it. And this was in the day when you would go highlight some sound on the screen, and you would press cut, and you'd walk away, and then you'd come back 5 minutes later, and it was ready to paste that sound somewhere. So it was actually a lot slower than cutting tape. The tape was actually a much faster process at the time. Once you got good at it. Even if you were really good at computers, they were slow. So I was really frustrated because I could play a drum and I could say something to it and it would say something immediately back to me. And I could be like, well, no, that's not what I want. Over here, something like this. And we could have this little conversation in real time about what kinds of sounds should come out of it. And it was great, and I spent a lot of time talking to my drums to get them to say the things that I wanted them to say. And the computer just wasn't ready to do that fast. So I said, well, how do I do this? And when you're in school, often the answer is school. You should go do more school. That's what the answer is. We were talking about credentialism. Obviously, so I went and did a master's in music technology at McGill, where I started to figure it out. And then it was really doing a PhD at the University of Victoria, where I started to put together some of the music, some of the hardware engineering, and some of the software to actually get this thing built, which was around 2004. And then since then, I've just been playing shows with it and iterating on it over time. And so I was at the Alberta College of Design for a number of years. I was very fortunate to spend some time at Stanford with the late Max Matthews, who was the very first person who said, "Why doesn't my computer make music?" He was sitting there in Bell Labs with a computer, which was like this big, and he was an engineer, and people around him were running engineering simulations. I said, well, why not a sound simulation? Why can't this thing make sound? And so all the things that we have that allow us to make sound came from his questions. Or all the digital things, not birds. Birds don't make sound because Max asked questions. Maybe they do. He was that fantastic. And so now I'm at OCAD. So I'm going to go back to the beginning again. So a lot of what I do, I find out later had started years before I thought it had started. So this is my grandfather, and he was a Luther. So growing up, I often sat in his basement on a pile of wood that would years later become a violin. And so that's where a lot of these questions started. It's like, when did my become this thing that's playing Beethoven? I don't know. When was that moment? Was it when it ran through the bandsaw? Was it when it got lacquer put on it? You know, and he would talk a lot about varnish, right? There's all this lore about blood and varnish is what made these certain violins so precious, right? The red violin. You know, did that have any effect? It probably just raised its value because of the intensity for it. But whether or not it makes it sound any better, don't know. And what was really interesting watching him work was that the same way we've been kind of playing around with computers and sound over the weekend, or Raspberry Pis and the world, he would play with wood. He'd buy a piece of wood not knowing, like, I've never tried this wood before. What happens when I do this? What happens if I dry it out for 6 months and then try and use it? What happens if I dry it out for 3 years and then try and use it? I don't know. And he would just run all these experiments with materials to see if stuff could happen. And if it would help him iterate his violin making. We can come to the first short answer so what do you do? My grandfather was a luthier, and so I call myself a digital luthier. I'm someone who makes digital musical instruments. So I should stop talking about them, and I'm going to show you. I'm going to show you an example of me playing one. Chris here on the left is about to break his instrument. He just broke it. And now he's upset that I made him get excited and break his instrument. So that's Chris Chafe. Chris is the head of the computer research, the Center for Computer Research and Musical Acoustics at Stanford. And that was a performance that we were, our first encounter together at the Banff Center in 2008 or 9 or so. Someone said, hey, there's someone who, okay. So here's a little bit of the instrument just by itself. Okay, so when I made this video in 2007, this was the first time that electronic drums could respond to brushes. Yes! This was the most amazing, this was years of struggle to be able to say, like, every time I hit a drum, I want to get some different results. And so here, this was, oh, no, play. Sorry. And it could also respond to anything. Whatever you hit it, right? You got a different result. Right? As it should. So now I'm doing some analysis. So when I hit the rim, change presets. So that was that's my doctoral thesis in 1 minute. Okay. So basically, what I was trying to figure out is how could I take electronic drums, which at the time really couldn't do enough of what I wanted them to do. I wanted to be able to take any mallet in my stick bag and play a drum each one of those mallets is supposed to sound different when you use it. So why don't electronics do that? Or why didn't they do that? They still, a lot of them don't do it. But I'm working on it. Someday they'll all give nice responses to different things. So I tried to figure out like what was it that I could do. So I could attach sensors to a player, which you can't. If you try and do that to virtuosos, they'll say like no, like every little gram affects the way they play. You can't attach things to them unless they're perfectly weightless and massless and invisible, and then maybe they'll do it. But the emperor's got no clothes on. So I thought, well, you can modify the stick, but again, that's something that expert players take a long time to get used to the feel of their instrument, their stick. So the only thing that was left was to modify the drum. So I modified it in 2 different ways. There's this thing at Karma that had been worked on for a number of years, which was physical modeling synthesis. So they were trying to run simulations of how would things sound virtually. So can you model a piano or a string or a cello completely in software? So can you model the sound of the string, its coupling to the body, its body to the air, and all and the bow, and the just infinite variations of control and interaction that's available. So what I had was a drum head, which was just a commercial electronic drum. And it turns out that inside of it, there's a contact microphone. Very simple, commonplace contact microphone. You can plug that into your computer and you get some sound. So what I had was a physical drum head, and a drum is really, here's where we can get my bias on things. You can think of it in 2 ways. You've got a skin or a drum head that's stretched over top of a resonator. So since I had the stretched head, and I had a direct source to its sound, I could simulate the resonator in software. And that would let me cheat, and anything that made a different sound on the head would make a different sound through the software as long as I didn't sort of destroy it with the resonator. So we got acoustically excited physical models. Instead of simulating the drum head and the stick in software, I just fed the microphone input into the resonators that were available and started to build some new resonators. Now the other part I wanted to figure out was I wanted the drum to know when certain things had happened. When you had hit it in the middle, when you hit it at the edge, when you hit the rim, when I picked up a different stick. I wanted to know those things so that I could change the state of the system while I was performing with it. So that's where machine listening comes in. That's my favorite. This is one of my favorite slides. So the guy who has headphones on. Another answer that I give people is that I was teaching computers how to listen. So I knew that what I could do was listen to a drum, and I could tell you if it had been hit in the middle or at the edge, or with a brush or with a stick. And so since those audio signals were there, is there a way that I could take that signal and have an output which was just the label? And so with a combination of digital signal processing and machine learning, you kind of put one into the other, make a computational model of the ear, make a computational model of the brain, feed the signal into the ear, and then the response of the ear into the brain, let it sit overnight and percolate, and then it can tell the difference between what was happening. So there wasn't a lot of this happening at the time. There was a lot of research about if you've got a musical signal, can you tell the difference between like a saxophone and a piano? And what I was interested in was, I've got a drum. I know I've got a drum. What I want to know is, which sound did this thing make? And so this is what I did, is I tried to figure out the different timbres that it would make. And it turns out that it worked. This is my favorite slide. Of all of them, this is my favorite. So this is my whole master's degree in one slide. And what I wanted to find out was, to what degree of accuracy could the computer discern these different sounds? And if you look really closely, you'll see there's a lot of like 99%, 99.3%, 99.6%. There's a 99.8 somewhere. 99.8. It's pretty good, right? You know, the computer can tell what's happening 99.8% of the time. The problem is that yeah, it's not really like that. And if your guitar works, if you go see a band and they play 99.8% of the right notes, they're terrible. Right? Like, that's just not high enough. If they play 2 wrong notes in a night, that's a bad band. You know, that's an even worse orchestra. Orchestras don't play wrong notes. You don't go to hear an orchestra that plays 99 or like 85% of the right notes. There's no way you'd think that the high school orchestra playing 85% of the time was good. They're terrible. So how could it be that your instrument was right about what was happening 85% of the time? It's not good. Yes, this was a success, but also a colossal failure. But it's something that I've been working with for a long time to try and figure out what kinds of interactions do I have with my instrument where failure is acceptable? And what kinds of musical situations can I get in where it's okay, things where I need to know, like, when do I need to know 100% of the time this is going to work? And when is it okay when not 100% of the time that it's going to work? I don't have all the answers to that yet. I'm still trying to find out how to build performances in such a way where I can still be excited at what's happening, I can get surprised, but I can also go in feeling prepared. You know, I don't want to show up on stage and not know if I'm going to be okay that night, because the audience wants to hear some music. So I'm going to play some music. So this is a show that I did about 3 weeks ago with Colin Labadie, who now lives in, or he's from Waterloo. And then we met in Alberta, and then we both moved back to Ontario about the same time. And so Colin has built his own really beautiful electronic guitar. Oh yeah. You book Colin for the next one of these and get him to, like, he's awesome. You'll see. Okay, so here's Colin and me. Okay, so that's the E drum set. So one of the things that I am really interested about is that it's like the drum set that I grew up learning, but it's not. So I'm really interested in the types of things that it encourages me to play, and then I'm interested if those things that it encourages me to play have application with the thing that I don't play anymore. So one of the things that I started doing was I started playing in multiple time signatures at the same time, because that was I thought that was kind of fun, and it really made me have to really think about what was going on at every moment, and where that moment was leading and where it was coming from, which is a little bit different in improv, but often improv is just about now, and maybe like a little bit from now, but with this it was making me think about larger time frames and whether or not starting one of these processes was going to, walk all over somebody else's idea. So I started practicing them and trying to get really good at them so that I could interject them without getting distracted in my own head while people were still putting out ideas. And lots of other people started making these kinds of exercises to get your brain working as well as not just your hands. So this was a thing that I got involved with. Another thing that started happening was more and more I was playing concerts with the same technology that I was using with the drum set, but without the drum set. So this is like a little portable rig that I used at intersections. Yeah, intersections, which is a day that happens in Dundas Square. So this was part of a laptop electronic improv thing that happened as a daytime event out in the public. And so I found that after a while I had enough chops with the drum set to be able to play the drum set. And the weakest part of of what I was doing was the computer. I was pretty good over here, but I was not super great at making sounds with the computer. And so, weakest link, I figured I'm not as good at this instrument as I could be. So I started playing the computer by itself in order to get better at the computer. Again, I do it in public to make sure that I'm accountable for, these goals. So I'm going to show you a performance that I did with these lovely dancers. The Vander Kroven, I always butcher their last name. They're sisters. And they lived in Edmonton, and they were also really interested in laptop sound. But the more and more we got playing together, they got really interested in the gestures of the laptop performer and how those gestures might actually be really similar to some of the really generic movements that people make that could be interpreted and exhibited as dance. And so we had a lot of fun talking about also the limits of when gesture becomes performance and when it can be moved from one context to the next. Their relationship on stage is fascinating to watch. It's so. Who else but six sisters would steal each other's books, and it's sort of okay. All right, so that was a lot of fun. Okay, so to that end as well, I've been I have two sort of solo non-performance projects that I do. The one is the one that I release, so I make these web albums every year to practice the computer and to make some stuff that I get out of my studio. Just you know, we've had some conversations about like when is the digital thing done. I set myself some deadlines that every year I have to make a new record and put it out and make it done. So I have a bunch of these projects. The one for this year is coming soon, and I have another project where I take all of the ideas that I think would be really good, that turned out not to be, and I work them into songs and things anyhow, so that they're done, and I never get tempted to use them on stage because they're terrible ideas. But they're enough of the ideas that they have to be seen to their end. They have to be seen to fruition, but just they're not really good enough for any. They're not good enough for your ears, or at least that one. So there's all this stuff. There's some other things that I do that I'll go through kind of quickly. At OCAD, I'm part of this lab called the Anthill, which is myself, Nick Puckett, and Tom Barker have this research lab. And when we tried to figure out what the intersection of our research was, we could just only think of the letters of our name, so it's Adam, Nick, and Tom, the Anthill. Nick does this really beautiful smart materials architecture work. Tom does these massive interactive public displays. And I do kind of random stuff. So I'm going to show you, this is one of the random things that I do. So, you know, not nearly as impressive as the Vibrofusion lab, but I've been looking at developing wearable vibrotactile gaming experiences for transmedia gaming for tweens, which is a cross-cultural collaboration between a research group in Toronto and a research group in Brazil. And we're interested in what are the similarities with the way that kids here and kids there interact with games and games that live on their body, and to what extent does the feeling of games affect either their ability or their perception of the game or their engagement with it, you know, or are tweens screen people? We're looking at that. We think it's a lot of fun. One of the other things that I do that I'm interested in is synesthesia. So it turns out that if you that a true color music synesthete, that when you get groups of them together, their synesthesias are different. They label different sounds as different colors. However, if you measure that same synesthete over and over again, they'll report the same sounds with the same colors. Now they also report a whole host of other things. They talk about space and materiality and the brightness and the luminescence of the colors that they see, the travel through space as they see them. It's not just like a synesthete's walking down the road, they hear some Britney Spears, it's just like purple, 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 and they can't see anything else, right? They get the experience of purple overlaid with a bunch of other things. So this was a piece of software that I wrote where I handed it to synesthetes to record the colors as they were experiencing them while they were listening to music. And this shows a number of respondents listening to the same piece at the same time, recording the colors that they're experiencing. Now, it doesn't show shapes or things. If you've ever seen any paintings that synesthetes do of a piece of music, you get the whole shape of their experience, but what you lose, and it's very descriptive, but what you lose is the temporal information. So this was an experimental piece of research to try and capture, catalog, and start to analyze the temporal information of the experience of the synesthete. Okay, so great. Another thing that I'm really interested in is, so I've got a computer, I've got another computer. We both want them to make music. Wouldn't it be cool if they made music together? How can we get these things to talk in any sort of reasonable way? With a researcher in Calgary, Lauren's wife, we worked on this thing called the Nexus Definition Exchange format in order to make it easy for musical instruments, which are now networked, to communicate with each other. In the beginning of electronic music, we had modular synthesizers, and then we had MIDI. And MIDI made it so that all these things could talk to each other. And MIDI was great, we got all this interchange. But then we got the 80s, and it was not so good. But we've sort of gone past that, and now we've made these things that use the pervasive networks around us, but we don't have any standardized protocol for saying, I'm not just sending a network packet, I'm sending a musical network packet. So this is one of the things that we're working on, to try and figure out how you know that the thing at the other end is trying to be music and not a mail server, right? Which is fun. So, okay, so I've been doing all this stuff. Now what? Well, there's this thing, right? It's been sitting up here, and I haven't touched it, and you're wondering why it would even be here, or what it is, or this thing. So this is the Madrona Labs sound plane, and it's a beautiful instrument. And basically, what it is a lattice theremin that's meant to pick up touches and do stuff. So it's this little touch interface. Yeah, so I got this thing and I was wondering what could I make it do? And I started playing with oscillators, and that's a blank slide. That's the slide that I wanted. What I was wondering was I had these oscillators and they were just kicking out sine waves over and over again. I thought, well, what I want is something that maybe does a sine and then a square and then maybe a triangle and then maybe like a dog bark, and then it just like changes from period to period what it is. And so I tried to look for the piece of software that did that, and there wasn't one. I found some oscillators that were out there that had like frequency and phase, but they didn't have a button for waveform, so I could change the waveform. So, like any sane person, what did I do? I wrote some software that tried to do that. Okay, so let me just go over here. So I can like make a. So here's our sine wave, and then this is what happens when you have a sine wave and the next period is a square wave. Fun. What about sine and noise? So you get something that's noisy but also has a strong pitch just by oscillating one period of noise and pitch, which I thought was a lot of fun. So what about like sine noise, sine square? Well, that's what that sounds like. And I was thinking like one and the other, but what about like two of one and two of the other? So like two noises and the two sines. Okay, so that does stuff. I thought that was really fun. Okay, so I'm going to do something else. Okay, so I'm done, except to say, so about this thing was made by a friend of mine, Randy Jones, who runs Madrona Labs. When I was doing my PhD and doing the first big round of the electronic drum set, this was his master's thesis that he was starting to work on. And now it's a beautiful thing. So the other name for that I was thinking for the talk is I no longer play the drum set. I played that gig with Colin about 3 weeks ago. I packed up my drums, I put them in the cases, and I've actually locked them away. And so I'm hoping that in 10 years I'll have something interesting to say about touch interfaces and what it's like to play this for 10 years, and if it's possible to use this in improv music or not. So if you're interested to see how much of a success or failure that is, you can find me at adamtindale.com. Every bit of code that I write that I don't forget to upload, I put on my GitHub page. So if you haven't seen me upload code for a while, just because I'm hacking and forget to press the upload button, I give it all away just because it may be useful, or it may not be. So I'm happy to take a question. Do we have some time for questions? And